36,000 kilograms outside Chicago. Wheels just dropped to the asphalt. Wheels designed to float, not for traction. A hidden legal formula forced that decision, and it reveals everything about how roads, laws, and load limits actually work. In the years after World War II, the freight industry faced a new challenge. Trucks kept getting heavier, but roads and bridges had not caught up. Engineers knew that simply adding more wheels was not enough. They needed a way to carry bigger loads without destroying the infrastructure beneath them. In 1952, Mack Trucks filed U.S. Patent 2,612,250 for a hydraulic lift axle, a wheel assembly that could be raised or lowered on command. This was more than a mechanical tweak. It was a strategic move, letting trucks adapt their footprint to the weight they carried. By 1956, International Harvester was running field trials with these new axles. The results were immediate, a 12% increase in legal payload without breaking the rules or the pavement. Early prototypes were simple, controlled by levers and basic hydraulics, but they set the template for what would become standard equipment. The lift axle was not just a clever gadget, it was a quiet revolution, born from the pressure to move more freight on roads that were never designed for such loads. These first floating wheels showed that sometimes the answer to a problem is not more power or more traction, it is knowing when to touch the ground and when to stay in the air. Legal weight limits for trucks in the United States are not set by guesswork or tradition. They are written into law with a formula that leaves little room for improvisation. The Federal Bridge formula reads W equals 500 times the quantity L times N divided by N minus 1 plus 12N plus 36. For a typical 5-axle semi-truck with 50 feet between the first and last axle, the formula allows a maximum weight of 36,000 kilograms. Add a 6th axle at the right spacing and the limit rises to nearly 38,100 kilograms, a full 2 metric tons more. This is not about adding power or making the truck tougher, it is about distributing weight so that no single axle overloads a bridge or stretch of pavement. The law rewards those who spread their load and punishes those who do not. For every extra axle that touches the ground, the legal ceiling climbs, but only if the spacing meets the formula's strict requirements. Each calculation is checked at weigh stations, and increasingly by automated sensors built into the road itself. The message is clear. In modern freight, every wheel is a legal strategy, not just a mechanical one. Across the United States, nearly 40% of bridges have outlived their original design life. Some date back to the Eisenhower era, carrying loads and traffic patterns their builders never imagined. As these structures age, the margin for error shrinks. A single overloaded axle can push a tired bridge closer to failure. That is why enforcement has entered a new era, one defined by sensors rather than stop signs. Weigh-in-motion technology, now deployed on major freight corridors like the Illinois Tollway, reads axle weights as trucks pass at highway speed. These embedded sensors can flag an overweight vehicle in less than 0.2 of a second, transmitting data directly to enforcement teams. For drivers, the window to make axle decisions has closed to a matter of moments. A raised or lowered axle is not just a mechanical choice, it is a real-time response to an invisible network of aging steel and concrete, monitored by algorithms and laser scanners. As more bridges reach critical age and as freight traffic continues to rise, the stakes grow higher. The floating tire becomes a frontline defense, not just for the driver's wallet, but for the survival of the nation's infrastructure. A loaded truck does not just weigh down the road, it multiplies the stress beneath every tire. In the late 1950s, engineers at the AASHO road test uncovered a startling truth. Pavement damage does not rise in a straight line with weight. It explodes. The math is simple but ruthless. If you double the load on a single axle, The damage to the pavement does not just double, it grows by a factor of 16. That is the fourth power law, and it is why axle count matters more than brute strength. A pavement engineer puts it bluntly, one heavy axle can do as much harm as dozens of lighter ones. Every extra axle spreads the weight, turning a potential 16-fold disaster into manageable wear. This is not just theory, it is the reason states invest in extra hardware, and why every pound matters in the battle between freight and the fragile surface beneath our wheels. Inside the cab, the decision to drop a lift axle is part science, part economics. Veteran drivers know the hardware by feel. A pneumatic system uses airbags and weighs about 350 kilograms, while hydraulic setups handle heavier loads but add complexity. Lowering a floating axle spreads weight instantly, keeping the truck legal and bridges safe, but it costs more than just a push of a button. Running with the axle down all day drops average fuel mileage by around 2%, a penalty that adds up over thousands of miles. Fleet fuel logs track every fraction lost, and drivers time their moves with precision. Sensors warn when a weigh-in motion checkpoint is ahead, giving just seconds to react. One driver puts it simply, you lower before the sensor, not after. For them, every axle is a wager. Fuel against fines, hardware against the law, played out in real time on every run. A truck approaches the Illinois tollway, sensors humming beneath the asphalt. The driver glances at the dashboard, payload creeping just above the legal threshold. In that instant, a pneumatic hiss signals the lift axle dropping, turning a 5-axle rig into a 6-axle rig. The numbers tell the story. With the axle raised, the truck stands at 33,100 kilograms, just under the maximum for 5 axles. Lowering the axle brings the legal ceiling up to 38,100 kilograms, a difference that can mean the line between a routine trip and a costly penalty. Illinois's overweight fines start at $650 and climb sharply for each extra axle out of compliance. Toll managers say, you pay for every wheel that hits the ground, but you pay a lot more if you get it wrong. In a single motion, the floating tire becomes the driver's shield against sensors, against fines, and against the invisible economics that rule the road. Every mile of freight moves within invisible limits, laws, formulas, physics, and cost. The next time a wheel floats, remember, the biggest pressures on our roads are the ones we rarely see. Subscribe for more hidden stories.